Dear viewers, you're most welcome to this first presentation about linear simultaneous equations. This is Algebra 2 Mathematics channel, and thanks for watching. If you are new to this channel, please kindly subscribe, turn on the notification button so that you are notified whenever I put in a video, like and share. Tonight, I'm introducing you to this topic, linear simultaneous equations containing two unknowns or two variables, as we are going to see. So we have our competence. Our competence reads, learners should understand, form and solve simultaneous equations. And below here we have our learning outcomes, which reads, by the end of this topic, you should be able to, we have part A, formulate simultaneous equations, same as form simultaneous equations. Then we have part B, you should be able to also solve simultaneous equations using any of these four methods, whereby you have elimination method, substitution method, matrix method, and then graphical method, whereby you be required to have understood how to draw graphs of simultaneous equations and estimate the solutions. Let us now dive in to the introduction to this topic, beginning with part A, that is forming linear simultaneous equations. Let us begin with part A. As you can see here, that linear equations with the two unknowns can be of the form cx plus dy equals to f, then ax plus by equals to e. We are saying that where a, b, c, d, e, and f are constants, and these constants can either be negative or positive, as we shall see, while the x and y are variables or unknowns. That is to say, we can have an example of simultaneous equations. They are here. We have 3x plus y equals to negative 2. Then the 4x minus 7y equals to 11. So in here, we can say that the constants are the 3, the 1, the coefficient of 1 is here alongside y. Then we have the negative 2, we have the 4, negative 7, and then 11. Whereas the variables in here in these two simultaneous equations are the x and y. Let us have examples so that you can very much or understand more about forming linear simultaneous equations containing two variables or two unknowns. Example 1. It reads, Maureen buys 3 tins of peanut butter and 5 tins of margarine at UGX 32,000, while Zuleika buys 6 tins of peanut butter and 8 tins of margarine for UGX 59,000. Assume they both bought from one shop. Mathematically relate the unit costs of items bought and expenses. Simply in here, they want us to formulate simultaneous equations containing symbols and words, and should be expressed mathematically. Let us have our response here. In here, we have Maureen and then Zuleika. What is the most important here are the steps followed when we are forming these simultaneous equations. Step number 1, you begin by letting. So we can say that let the unit cost of peanut butter and margarine be x and y respectively. So after letting, this now coming to be our step 1. After letting, then we have to go ahead and analyze the statements. Here there are two statements that need to be analyzed. The first one is talking of Maureen buying 3 tins of peanut butter. So let us begin with that. Maureen, this is Maureen. Maureen bought 3 tins of peanut butter. Then peanut butter, the cost is x. Let us say she bought 3 peanut butter but multiplied by the unit cost, which is the x, plus 5 tins of margarine, so plus 5, multiplied by the unit cost of the margarine, then should be equal to the total amount of money she used, which is the 32,000. So this now becomes our first linear equation. Remember, we have also Zuleika. So now for Zuleika, it reads that Zuleika bought 6 tins of peanut butter. So we have 6 multiplied by the unit cost of peanut butter, then plus 8. So she also bought 8 tins of margarine multiplied by the unit cost of each. Then should be equal to the total amount of money she used, which is 59,000 UGX. So this one now becomes our equation 2. So in here, these are the simultaneous equations that were required or one could form depending on these statements given. The equation number 2, we can say that you can reduce by a factor of 2, and please, if it is possible, when there is a common factor, reduce. But for the meantime, we are just knowing how to form these simultaneous equations. Let's have example 2. It reads, two numbers are such that their sum is 27 and their difference is 13. Express the statement mathematically in order to relate the two numbers. Still, we are going to begin by letting. So we can say that let maybe x and y be the two numbers, and maybe x is greater than y, implying that now we go to step 2, where we need to analyze the statements or the statement. Let's say that two numbers are such that their sum is 27. So now they are talking of the sum of the two numbers. So we could get x plus y, then it should be equated to the 27. This gives us our first linear equation. Then it continues to read that, and their difference is 13. So in here we have to be considerate. The number x, or represented by x, is greater than y, and since we are getting a positive answer after the difference of the two numbers, it means that we must begin with the x, then followed by y, and in here we are getting the difference. For the difference, we have x minus y equals to the value talked about, which is 13. This becomes our equation 2. So now this one becomes our two simultaneous equations. Alright, let us proceed to number 3. It reads, a farmer found out that he can buy 2 bulls and 5 sheep for shillings 3,650,000, or 3 bulls and 6 sheep for shillings 5,100,000. Write down the equations using symbols. Still, we are going to do the same. We can let x and y be the unity cost of a bull and a sheep respectively. So now after letting, we need to analyze the statements. It reads, a farmer found out that he can buy 2 bulls. So in here we can talk of the bulls and then the sheep. So the farmer bought the 2 bulls. So 2 multiplied by the cost of a bull, 1 bull, whereby we are going to have 2x plus the number of sheep bought in this first statement are 5 multiplied by the unit cost of a sheep, which is y. Then this should be equal to the total cost used, which is the 3,650,000 shillings. So this gives us our first equation, which is now we're naming equation 1. Also, we are saying that 3 bulls, so we have the 3 bulls, 3 multiplied by x, plus the 6 sheep, so we have 6 multiplied by unit cost of a sheep, should be equal to the 5,100,000 shillings. So this gives us the second equation, which we are naming equation 2. So now this becomes our simultaneous equations from these statements. We can proceed to the next. So we have a tryout. To try out this, we have number 4, number 5, and number 6. Please try out them. Try to formulate the simultaneous equations, and please define your variables. Define your unknowns very well. And thanks for watching. See you again. Goodbye.